Hi everybody, in this video I'll be talking about basic trig ratios and how to work with them. Basic setup is you have a right triangle and these trig ratios work only with a right triangle. In this setup here I have a right triangle with angles A, B, and C and sides A, B, and C. You'll notice that the angle labels are capital letters, but the labels on the sides of the triangles are lowercase letters. And this is a good setup when we get to for when we get to laws of cosine and laws of sine. But one thing at a time. So first, for the trig ratios, we have sine, cosine, and tangent. Now there is a way to remember this, and it's called SOHCAHTOA. So is related to sine being opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be the opposite over the adjacent. So that's where those letters are coming from. When you look at this example here, actually putting things into this setup, it becomes like this. So for the sine, what we actually have is the following. We choose an angle, first of all, to focus on. And being that there are three angles, whichever angle you want is fine. Typically, though, it's the angle that is not the right angle itself. So in this case, it would be either A or B. I'm going to go ahead and choose angle B to focus on, okay? Just because it might help with our perspective a little bit. So focusing on angle B for all of these, left to right, it would be the sine of B of that angle is equal to. Now the opposite of angle B would be side B, as you see over here. So that's going to be B over the hypotenuse is C. Okay. For the cosine, it would be cosine of B is equal to the adjacent. The adjacent side is a side that is usually it is right next to that angle, but it's not the hypotenuse itself. Okay, so in this case, it would be side A over the hypotenuse, which is C. Now the tangent is opposite and adjacent, and it does not involve the hypotenuse at all. So if we go back to angle B, we would say the tangent of B of that angle would be opposite. Opposite of B is angle B is side B, and the adjacent side to angle B is side A. So this would be the setup for whatever you're trying to figure out, whether it's the length of a side or the value of the angle B itself. All right. One last thing I want to remind you of is that when you actually want to find the value of the angle, then you'd have to do what's called the inverse trig function, which in this case would be something like this. So you would say that the measurement of angle B would be the inverse sine of whatever you get from B over C. And the same thing would happen for cosine, and the same thing would happen for tangent. It would just be the inverse of those trig functions. So this would be the measurement of angle B is equal to the inverse cosine of A over C. And since I'm doing this, I might as well finish it. This would be the measurement of angle B would be the inverse tangent of B divided by A. And you would probably need a calculator for that unless you have a table. So with these things in mind, let's go ahead and jump into our examples. I have three lined up for you. Here we go. Example 1 is specifically an example involving sine. Now, in this example, my task is to get the value of the sine of C. Okay, so I want to figure out what does that become. Now, the sine of C is telling me that my focus angle is right over here. Oops, wrong one. I meant to highlight that. So it's C. That's my focus angle. Being that this is sine means that I will have to set it up as the sine of C being opposite over hypotenuse, which means that the sine of C would then be 28, which is opposite if you trace the steps, and the hypotenuse would be 35. So 28 over 35. Now 28 divided by 35 is actually 0.8. So 28 divided by 35, 0.8. So the sine of C would be 0.8. Now, at this point, this is all the question wants, but if I wanted to take this further and figure out the actual value of this angle here, angle C, I could then do the inverse sine of 0.8. So I would say the measurement of this angle is equal to the inverse sine of 0.8. Again, I need a calculator for this, so that would give me 53.1 degrees. So this would be measurement of angle C is equal to 53.1 degrees. Make sure when you do this that your calculator is in degrees mode, not radians mode. All calculators have a setting for this, so just make sure to look into that. And that's example 1. In example 2, we're dealing with cosine. Now with cosine, we have to remember what that means. So cosine, again, our focus angle here is angle C. Cosine involves the adjacent side. Now the adjacent side, again, is a side right next to that angle, but it's not the hypotenuse itself. So that would be 16. Actually, I'll set it up first. So it's cosine is equal to adjacent over the hypotenuse. And that means that we have cosine of C being equal to 16 divided by 34. Now 16 divided by 34 is 0.4706. So cosine of C is equal to 0.4706. My advice is when you're doing this, the intermediary steps should have decimal places out to about maybe 4 or 5 spaces after the decimal. When you give the final answer, it's a good idea to round it to the 10th place, just to be accurate. Okay, so at this point, if they only want the cosine of C, we're done. But if we want to take it a step further and get the actual value of that angle, we would say that the measurement of angle C would be the inverse cosine of 0.4706. So that would be, if I use my calculator, inverse cosine of that would be 61.9 degrees. So 61.9 degrees. And that's the value of that angle. In our third example, we deal with tangent. Now, tangent, unlike sine and cosine, does not involve the hypotenuse at all. Now, it says here, we want to get the tangent of x. Now, our focus angle is right here, so it's x. Okay? So, if I want to get the tangent of that angle, what I need to remember is the relationship between the sides. So, tangent of x would be, in this case, it would be opposite over adjacent. Now, if I substitute numbers for opposite and the word adjacent, what I get is tangent of x is equal to, the opposite of x would be 32, and the adjacent side would be 24. So 32 over 24, I'll write that better. Now 32 divided by 24 is 1.33 endlessly. So we could say the tangent of x is equal to 1.3333. Again, about 4 or 5 places after the decimal is usually a good idea. At this point, if they only want the ratio for the tangent of x, you're done. But I want to take this one step further and actually get the measurement of this angle, x, right there. And that would involve using the inverse tangent of 1.3333. So doing that would give me 53.1 degrees. So the measurement of angle x is equal to 53.1 degrees. And with that, we are finished. So I hope this video helped you out. Make sure that you set it up correctly. That's key here, setting it up correctly. One thing that could help you out is if you just go by SOHCAHTOA, which is right over here. SOHCAHTOA really is a good way of remembering the correct arrangement of these sides as they relate to sine, cosine, and tangent. So please stop by, leave a comment. Thanks for taking the time to watch. Bye-bye.